So the moment everyone's been waiting for, blah, blah, blah.
Yeah, it's been some time.
Yeah, so the moment everybody's been waiting for, the taillight prototype. This again is a prototype. This is not the final, how everything's gonna be set in. We're really just testing these lenses. But so before I go into any detail at all, we're gonna have Alex do a very good description of how he built these and everything like that, and what we're gonna do to change them in the future and stuff like that.
Yeah, he has like a bunch of tips and tricks, and
He literally built these from scratch.
Yeah, like for people I guess that do 3D printing, I feel like this will benefit you all quite well.
So we're gonna go into Saturday's footage.
Oh, we were gonna lay this out on the ground so I can explain the wiring. We can do it in here.
Yeah, I figured we had.
Wow, these look really fucking good. This looks super sick. I'm super glad we actually clear coated. Today on Chris Fix's YouTube channel, we're gonna repair a 240Z that's all carbon fiber.
Well, we're here now.
We're here. This little baby boy. This is for your mini 240Z.
This is Alex brought us this from the Midwest.
So I flew all the way from Midwest to deliver Tim this.
Thank you.
Yeah, no problem.
All right.
But actually, we did, I guess, a set of actually functional 3D printable or 3D printed taillights. I guess you're probably wondering why I'm here from the Midwest, why I came here from Wisconsin. My background is kind of in 3D printing. I have a little store called Airworks. We did a set of turbofans that were fully 3D printed on Larry Chen's Roush Mustang for SEMA 2019. And I've been following Industry Garage for like 2 years now. And I've always wanted to work with Street Bandito, Industry Garage, doing cool stuff. So when Tim was like, can we 3D print some sick taillights? We ended up coming up with, we don't have it ready. Where is it?
1 second, I'll be right back.
Man, he couldn't wait to use the skateboard.
My demo rolls in the frame. Yeah, so we 3D scanned the original Datsun 240Z taillights, and we ended up coming up with this FDM 3D print, which FDM is fused deposition modeling, which is just like a traditional 3D print where it's like a hot glue gun on the end of some motors. We give it a honeycomb pattern. I did not make the honeycomb pattern, that's just the infill from printing it. But we were kind of, I mean, that was when you were still in pretty early stages with this.
Yeah.
And we've been looking to do something more radical with my new equipment, and I now have the ability to print these. I was like, hey, if we wait, some months, I'll have the ability to print these optically clear so that they look like glass. So these are printed on a direct light projection printer, or DLP, which is basically the whole print is done submerged inside of a tank of resin, and it exposes a layer of light or an image for the layer, and then it pulls the print out of that vat, and it keeps exposing different images, which represent.
You watch Westworld?
Yeah. No, it's literally that.
Okay.
When I first fired up the printer and sent pictures of it, people were like, "That's the most Westworld shit I've ever seen."
Yeah. I was just about to say,
but
it sounds like Westworld.
That technology hasn't been around to make big stuff yet. So now that we can do bigger parts, I was like, why not just do some taillights?
Yeah.
So we ended up doing, like, this is a set. This actually still needs to be cleared on the backside, but this is what the print pretty much looks like when it has some clear on the front. We still gotta do the backside, and then it'll be a little bit more clear, but
Yeah, like the white haze will all be gone. So
yeah.
And this is for the headlights.
Yep.
Yeah.
This is a headlight lens, and it's got a separate printed piece in here. This was not printed in one piece. It's a press fit thing, but what this resin actually is, for those of you who are wondering how it withstands being in an automotive environment, we're still kind of figuring out what's going to survive.
Yeah, we're testing.
Yeah, I don't want to be the guy who comes on and just be like, this is all going to work and it's going to be great.
You know what I'm about to say, right? R&D.
Yeah, exactly. But it should hold up because, and if you're at home with a cheap resin printer off Amazon or something and you're just experimenting with it, totally try mixing resins. All of it is urethane acrylate. So like this stuff is just clear urethane acrylate, and it has a photopolymer, like, I'll kneel so I'm not towering over it like a giraffe. Has a photopolymer like initiator in it. I'm not entirely sure how it works, but basically you can take a stiff resin that's clear and a flexible resin that's like an additive that's rubbery, and you can mix them together to get the ratio of stiffness to clarity that you want, and that's what we've done here. So these are probably between 60 and 80% just clear urethane acrylate, and the rest is all flex additive, so that like you can take these and actually twist them like 3-4 degrees before they start to crack. And I did that on the test one, and it was pretty resilient.
How do these hold up to heat?
So since that's another thing.
Test.
We did do a test actually with the
I'll be back.
PETG lenses. By the way, these lenses are PETG if you want to make them out of FDM. But Tim will grab the test. But these guys, the advantage of printing with a light projection printer is that they're cured with light. So the temperature aspect of the glass transition temperature of the material doesn't have to be suited for printing on, like an outlet from your house with a little just extruder on a cheap printer. It can be suited to whatever these materials want to hold up to. So,
And we literally had this LED headlight base that I wired up, which these LEDs are super overpowered, and we're never going to run these at
they're toasty.
100%.
Yeah, and you measured
And
those.
this was literally, you can see this piece was
on it.
literally sitting on the LED.
Yeah.
And after like 6 hours, it started to warp in the center.
Yeah, with no cooling and anything. But that's PET.
Yeah, so this is printed completely differently, and it's not nearly as thick.
Yep. So
And
this material, for reference, just for people who aren't super familiar with like material science, this is the exact same plastic, pretty much, that like a Coca-Cola bottle is made out of. So
Yeah,
it has,
I was just about to say, I remember somebody actually mentioning that
yeah.
a long time ago.
Yep. So it's really great for doing this kind of stuff, because if you print a shape laying down like this and your strand is continuous this way, you have a lot of like hoop strength this way. And if it melts, it won't tend to just crack over time. It'll just stay melted.
Okay.
But the glass transition temp on this, I think, is like 80 degrees C or something like that. And the melting temp that you printed at is like 260.
And this got to like 160 something.
Fahrenheit.
Yeah.
This,
Fahrenheit.
yeah, these resins can withstand a lot more, solely because they're not designed as thermoplastic. So these are literally designed to get soft as they get hot. These are not. So these just cure with light at 60 degrees. This whole print was done at room temperature, including all of the workings of the printer.
And it's a UV light that cures it, right?
UV light that cures it, and then if you want to have a more heat-resistant part, you just add heat-resistant resin from various engineering suppliers that sell it.
How did you go about, like, I guess if somebody wanted to attempt to do this at home, what tips or like guidance would you recommend?
Yeah, so if you wanted to do something like this at home, where you'd want to start is go on Amazon or go on eBay and search DLP printer, and there's loads of them that come up. There's like some that go down to like $250 for a printer. It's really cool. And they're really rudimentary, and you do have to put it in like an area that you are okay with just ruining, because you will have issues and you'll have to drain resin all over the floor and stuff like that. And it gets really smelly. But there's only one moving part on a DLP printer, which is the print bed itself. So calibrating them is actually super
And it
simple.
only moves
Vertical.
in a vertical, yeah.
Yep. So yeah, after you find yourself a DLP printer online, find an area to put it. After that, you're going to be basically just trial and error with different resins and different exposure times. And that's about it. You can make whatever parts you want doing that. There's actually a wealth of knowledge on the internet for how to use these new style of printers. And they're not really new. The technology's been around for a long time. But now that it's available to us, just enthusiasts.
It's not even just that, the power of Google.
Yeah.
So I guess it always comes down to like how bad someone really wants to learn it.
Yeah.
But just showing like if you are capable of doing it.
Oh, for sure.
Yeah.
Yeah, and like I
Don't
mean,
let him fool you, he's the genius.
Yeah, he is like a super genius.
I mean,
but
I'm a test engineer. I never went to school for 3D printing or additive manufacturing or even controlling CNC systems. So you can do it just by Googling it.
so there's this little box here. Sorry, I didn't
So-
cut you off. But
All of this wiring here, and this is, just keep in mind that all of this is version 1 prototype. The
Yeah,
final
so-
prototype will have an actual PCB made. I've
It
done.
is a prototype.
It's
Make
fully
that very-
prototype.
This is a prototype as well. I mean, the first lens was a good test.
The first one was
this is
proof
the-
of concept.
yeah,
This is an actual prototype.
First prototype.
So please don't judge the wires everywhere. I tried to heat shrink it as best I could. So, except for the controller. You can blame me for that.
It's got tape on it right now.
It's got literally packing tape on it. But so just a quick rundown on the electronics, and I really want people to not be intimidated by this solely because you could totally learn how to do this in a weekend just by Googling stuff, and this is like $30 in electronics if you screw it up. Definitely go ahead and try it.
Yep.
This, we'll just start from the beginning. Most expensive workbench I've ever demoed something on. So this is a step-down converter. So what this does is it takes in your 12-volt switch power here, and then your ground to chassis, and it just converts it from 12 volts to 5 volts. And this is rated at being able to move 25 amps of heat, basically.
Okay.
Or, 5 times 25, 125 watts of heat. And then in here, this mess, we have two things that make this whole thing work. There is the microcontroller, which you could basically replace this with an Arduino. We've gone with a TeenZ 3.2, which is just basically like a commercially available ARM processor, like you'd find in a phone, but then made readily available to us with an Arduino programmer. So any YouTube tutorial or built-in program that's in the Arduino software, which you don't even have to type a single line of code to run that on this. So you could buy this, put a zillion sensors on stuff, and then just copy and paste code if you wanted to. Yeah. But this is just a more serious, more heavy-duty chip to use. So this is the controller for everything. But the most important part of this whole setup that I think is not super well known about on projects like this is this optocoupler. So this little guy, this little 4-pin chip here, it's a Sharp, what is it? A Sharp 817C, I think it's just 817 is the general package and everything. But what this is something that I'm about to explain on a piece of paper. So inside of this chip, there's 4 wires coming out of it. Basically there is your circuit coming in here and your circuit coming in here. This guy over here is going to go to like your signal from the car. In this case, we have a brake light signal, so it's literally the same signal that the bulb in the taillight would see. Super straightforward. This guy is going to go to ground. And in here, this is inside of the box of the little chip. So this is that tiny little black box. On this side, there is, and I'm going to totally biff the actual symbol for this, so I'm just going to draw a little squiggly because incandescent light go. In here is an infrared LED. So it's literally just like an infrared LED that you would find on, like a TV remote or something like that. It's an infrared LED. On this side, this is a photo transistor. So basically, this is a switch and this is a light. And what happens here is that this light, as soon as it is turned on, just connects this switch to, closes this switch. And you have to calculate a resistor across the signal here. So like to not fry your microcontroller and to just be safe. You could probably theoretically wire this without those things and maybe be fine for a little bit, but it's super easy to calculate those resistances. We'll link a video of the video that I use to calculate the resistances. It'll take you 30 seconds on your phone calculator. Super easy, not intimidating. When you close this phototransistor, you can take a 5-volt signal and you can pass it through to your controller. So if you're looking at this thinking, well, what's the benefit of this? Why can't I just route 12 volts straight to the controller? If I just put 12 volts from this car straight into the analog input of this controller, it would definitely blow up. Because most of these controllers are below 12 volts logic, actually all of them are below 12 volts logic level.
5 usually or something?
Yeah, so they think in 5 volts or they think in 3.3 volts, which this guy does. This is actually a 5 volt tolerant one, so it has a little step down built in. But 5 volts is the max. So what this does is it allows you to read something going on over here on your car, or whatever you may have. You can have a 120 volt signal here, and you can read it on a totally isolated circuit over here. So even if your alternator fails or your regulator fails and you go to like 40 psi, you still will be able to you still will be able to use your system without it being damaged. Now, I've kind of not done that super well here because I've joined the grounds together, so it's not really a closed system, but it's just
power running to it is
exactly. It's totally isolated.
Only thing I say is R&D.
Exactly. Hey, that proves that you can wire this kind of half-ass and it still works. But anyway, so that's how an optocoupler works. You can buy these on Amazon for like $8 for a pack of like 100. So you can literally use them for anything. They're super useful. I would use them for a ton of different projects. You can also pulse width modulate them, which if you're getting a little bit more advanced with like what you're doing with controllers and writing your own code, you can actually send, like let's say I sent a 50% load pulse width through here. So let's say I was like opening a valve, and you can actually detect on some optocouplers, I think the Sharp 817C lets you do it, but you can actually detect a pulse width modulated signal across here, which is super cool. So in the car, we have a signal going from switch 12 volts to this big guy, ground to this guy, and then the only other wire in this whole setup is just a switch 12 volts going to the brake signal.
Okay.
In the future on V2, we'll have like turn signals left and right. And then the cool part about that is you can, obviously with a microcontroller, you can do whatever you want with lights. You can do whatever you want with turn signal animations. You can tell it to input a signal and ignore another signal. So,
That's where we're gonna light them up right quick.
yeah, let's do it. I feel like that was reasonably understandable.
Yeah. Hey.
I highly doubt the faint heart is really gonna take on this task, but for the few that are bold enough, you have a plethora of information.
So originally I was kind of thinking, I was maybe being a little bit too ambitious, but I wanted to do something similar to like the Aston Martin Vulcan taillights, which if you can show a picture of it, but they basically have these kind of impossibly shaped little acrylic rods that come out, and they're all light tubes. And I wanted to do something like that, but that's not really practical or necessarily tasteful for the people who are going to be just putting these taillights on a more stock Z. So we kind of wanted to use and experiment with some of the light tube functions of the urethane. So I put in a couple extruded ribs in here. We haven't really fired these up with the new clear coat on them, so
True. Yeah.
we'll find out.
Patiently waiting for Tim to.
We might sand the edges of them if they.
Yeah. So if you want to print a light tube, which by the way, a light tube is like a light, or I guess it's called a light pipe. Basically, what OEs will do is they will model, or sorry, not model. There you go. They would make this piece in one mold, and then instead of trying to somehow cut an EL panel, electroluminescent panel, to be this shape, they just run a single LED, maybe 2 or 3 along this edge, and it disperses into the shape, and then the back of it is white, so that way it bounces back out.
Or they scuff it in some
Right.
way. That's why it looks kind of white versus the clear edge of it.
Anything
you,
that diffuses light
Yeah.
instead of lets light pass through,
Yeah.
you'll see. So on the edges of those light tubes, we might just scuff it with some sandpaper and make them diffuse more, and then you'll really see those fins. To everybody who's going to give me crap for having a 72 megahertz microcontroller hooked up to it that's super powerful and only running 2 animations, we're working on doing multiple animations. I just also work a 40-hour-a-week full-time job.
Oh, I wouldn't even explain it to him. You just told him R&D. When in doubt, R&D. That's it.
But we're gonna. The cool thing about having individually addressable LEDs is that you can really do whatever you want. So, for example, I personally am not a fan of when LED brake lights come on and they're just instant and it kind of shocks your eyes. I think it should be more like an incandescent light, glow up. And we can just program these to do the same fade on with just pulse width modulation. And then when you hit the brake pedal, it'll just increase a brightness value, like a global brightness value, from let's say 30 out of 255 to 255 out of 255 with a delay value of 1 millisecond or something like that between each brightness increment, and it'll just go through that loop really quick. That way, it'll be nice and soft, and you can do all sorts of stuff like that. So we're gonna have tons of cool animations. I actually am thinking of maybe putting a dip switch on the circuit board, so if you have a classic Z and you want just a solid taillight, you can do that. Or if you want something more radical and you want animations, you can just flip the switch and have those.
Currently.
Yeah.
Oh.
Whoa.
All right.
Whoa, the whole light tube thing totally works. Do you want it? Should I program anyone on a party mode thing to just watch it? Yeah. Dude, you can totally see all the little X's too. If you want to do close-up B-roll of it on. Actually, you might not want to do that because it's ugly a little bit up close.
R&D. R&D.
Should probably take this thing, so I don't know. I'll have to redesign that.
Max, your face looked dope.
One thing to learn,
The side of your head was like red light.
This is a learning process as Timothy kills the lights.
I kind of